Hello everyone, welcome to this video. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to do zonal statistic using land covers data in the Earth Engine platform. Zonal statistic is one of the useful functions that allows you to get statistical information for each land cover separately, and basically most of the users need to know about this function in the Earth Engine. So this tutorial is useful for beginners, but I'm suggesting you to use this tutorial to get statistical information from these different land covers in your projects. So first of all, we need to select the region of interest. I'm gonna select a basin in Iran through the hydroshed dataset. Go to search places on dataset and type for hydroshed data level 5 is already available. Import it to the code as a table, then you can have it here. Through the map.add layer, I'm gonna visualize the basin layer for the global region. This tutorial can be used for all around the world, not limited to a specific data or region of interest. You can use it for all regions in all around the world. So imagine that here Iran is my own country. I'm gonna select a part of Iran, a basin in the northwest of Iran to show you different land covers we have here, and then I'm gonna show you how we can get statistical information about the amount of temperature and about the amount of vegetation cover for each land cover separately using a statistical analysis simply. So then we need to select. So now I'm gonna select the target basin, that it is Urmia basin in the northwest of Iran. You can use this tutorial for your own region of interest, and also not limited. Don't limit yourself to the region I'm working. Try to do this tutorial for your own region. So through the add marker here, I mark the region of interest first, and then I can actually filter out my region of interest through the filter bound here. Make a new variable as a ROI. From input table, I'm going to filter all. As you can see here, we will have the filter bound. I'm gonna filter the features based on my own region of interest that is already marked through the geometry you can see here. So through the map.center object, we can have focus on the ROI, and we can visualize the target basin or Urmia basin. Get rid of the previous map.add layer. Remember to save your code and run it again. After a few moments, we will have focus on the study area. And now, as you can see here, the region of interest selected and clipped and separated from the other features that we had already. So, and before go further, I recommend to simplify the shapefile you are using. In the previous tutorials, I always mentioned about simplification process and generalization. But if you go to the hydroshed data, you can see that we have no generalized hydroshed data here, and all of them originally published on the Earth Engine. For some of the shapefiles, such as the FAO data, as you can see, FAO administrative level, as you can see, some of them already simplified and available on the Earth Engine. But FAO data is only useful for administrative units such as provinces, cities, and country borders. For such kind of borders, the FAO is okay, and you can use simplified version without further simplification. But when you are dealing with a hydroshed data set, it is important to do simplification process before actually going forward. Now, after region of interest selected, you must make a new loop, define a function, the input feature called as a feature, the function returning the input feature that is simplified based on a degree of error. For example, I'm going to use 1000 degree of error. Remember that we want to do simplification to have the region of interest with the exact or already same or almost same border, but with the lower number of vertices. So now when you run a code here, print ROI.geometry, you can see that here the number of vertices reduced to 500. So we have almost the same area without any big change, and also with the lower number of vertices. Now imagine that if we don't have a simplification process, in that case the number of vertices is around 2000 vertices. That's very heavy and also too much for the web processing or web data analysis. When you are dealing with the servers or doing cloud computing such as Google Earth Engine platform, it is important to simplify your data as much as possible. That highly helps to increase the speed of processing and helps you to manage the resources allocated to your account from the Google side. So let's back to the previous structure and simplification. And now you can see we have the simplified version of ROI. And now we can go further for the next analysis. In the first step, I'm going to show you what kind of land covers we have in this region of interest. That's why land cover is a new variable created here, and then through the search places and dataset you can find the modest land cover product available here. Modest land cover product already available with 500 meter spatial resolution and also with the annual temporal frequency. That is very important. It's available since 2001 to 2023. Imported into the code. Actually, it's going to be updated in the next years as I'm producing this tutorial in 2024. This product is available until 23, and definitely after each year it will be updated based on previous year. So land cover variable created. Now I'm assigning image collection to the land cover, and now I'm gonna make a single layer of land cover through the mode statistic function. The mode helps us to actually find the most frequent classes per each pixel, and we can have a final land cover that shows the most frequent land covers or most frequent classes over the last 20 years. And then, as you may know, if you go to the data characteristic here, we have different land cover types based on different standards, but typically users use LC type 1, and this will be our target layer in this tutorial. So LC type number 1 is selected, and no need to use a filter date or filter band because specifically about the filter bond, we don't need to have one of them because the modest land cover data doesn't follow framing structure, same as what we have in Landsat or Sentinel data. In this case, for each year we will have one frame for whole of the world. In that case, no need to actually filter your data based on the region of interest. Just call your data, define the temporal filter that is removed through the mode here, and then select the target land cover that is already selected here. So now I'm gonna do a visualization to get more understanding about different type of land covers that we have in this area. So through the map.add layer, you can do the visualization. Map.add layer is a popular function for the visualization process. Most of the users asking me how you show the rest of the code or arguments, just same as what I did now. You can do this by pressing Control and space together, and here you can see if I back, and here inside the parentheses, if I press on Control and space together, you can see the rest of the codes or optional and necessary arguments that we have here. Earth engine.object refers to the image that you want to visualize, that here could be the land cover data. What about the visualization parameters? As we have 17 classes in this land cover, you can use the visualization parameters already defined for this product. If you go to the data characteristic page here, you can get some preliminary information about the kind of data you are working And also here, already visualization parameters defined through a separate variable in the code example you have access here. For all of the codes in the Google Earth Engine, if you go to the data properties for each product, you can find an example code that helps you to get understanding about the code's functions and also how to do some basic process for that product. That could be very, very beneficial for the beginner users. Now, just copy and paste it into your code here. Instead of visualization parameter, we have actually a new variable including minimum value, maximum value, and also the color palette for each class. So I change its name to the V's, or visualization stands for visualization, and also the layer name will be the land cover, just like that. And shown should be false, because we want to avoid automatic visualization that highly reduces the speed of processing, and it is important to turn it off first, but then you can show the final results, instead of showing automatically. So remember to clip it based on the region of interest through the .clip, region of interest already defined and simplified through the ROI. So as you can see here, we have a land cover data, different land covers available for my region of interest. We have the water bodies, agricultural area, and also the urban area, bare lands. If you don't know about the different land covers, there is a simple trick here. Go to the inspector and click on the target pixel. Here you can see LC type or land cover pixel type or pixel number. Then there is a table of content in the bands here. You can find it. For example, number 17 shows the water bodies. Or if you pick another pixel, for example, another pixel is land cover type 1, number 10. The number 10 referred to grassland. So this kind of actually the table of contents that we have here helping us to get understanding about the association and relationship between the values, pixel values, and also the colors that we have here. So this is about the land cover for the region of interest. After you get information about the region you are working, now we can call NDVI and, for example, the temperature data to get more information about the amount of NDVI for each land cover, or amount of, for example, temperature for each land cover separately. That could be very beneficial for our studies. So now I'm gonna call, for example, NDVI data first. Make a new variable as NDVI equals to, go to search places and dataset again and type NDVI, modis NDVI actually. So modis NDVI products, all of them listed here, some of them from Aqua and some of them from Terra, no difference with a kind of satellites. Just the important thing is a modis NDVI product with 16 days temporal interval, temporal frequency, and 1 kilometer, 500 and 250 meter. If you want to get more details about each land covers, I am suggesting to use 250 meter spatial resolution, import it into the code as a second image collection, then assign the second image collection to the NDVI, just what we have here, and then define the period of time in which you want to actually assess the amount of vegetation in each land covers. So through the filter date, the period of time I'm gonna work, for example, is related to 2020. I'm gonna see that how much vegetation coverage actually, how much NDVI do I have for each land cover according to the NDVI values in 2020. The start date 2020, the end date 2021. No need the filter bound, as I mentioned earlier. If you go to the data characteristic and properties, you can get more information about the bands, scale factors, and the rest of the information. As you can see, this product is available since 2000. Here, go to the bands. As you can see, NDVI, EVI, all of them available. But we have a scale factor as this value that should be applied on the NDVI. So Now I'm gonna get an average for 2021 because I'm gonna have an average from NDVI for the whole of the year, and then actually get a statistical information based on NDVI or average NDVI for 2020. That select allows me to select the NDVI band. So then I want to have, I'm going to actually calculate the average value. That median is a helpful function. Median and mean works really closely, but the main difference is median less affect from the extreme high or extreme low values such as cloud cover or satellite internal noises and on. So here we have median or calculated, and now we must multiply the median to the scale factor already copied. So, and paste it here, as you can see. So NDVI is ready. Then try for visualization through the map.add layer. Now I'm gonna visualize NDVI that is clipped based on my region of interest or ROI. No need to the visualization parameter, leave it empty, and the layer name will be NDVI, and shown should be false to avoid automatic visualization, and skip the opacity, just like that. Run a code again, and after a few moments here you will have the NDVI image, but seems there is a problem about the NDVI product. As you can see here, reduce.median, and here we have a problem. Layer error, reduce.median in ID1 image.cycle band pattern NDVI didn't match to any bands. So let's try it again. Go to the band characteristic. Here we have NDVI layer. Copy and paste it to see what the problem is. NDVI. Let's see what the problem is here. Remove the median process and run a code here. NDVI.clip. Let me to get a print to see what the problem is. Here, step by step, we can assess the issue we faced. So here, still we have a problem. Oh, the problem back to the kind of image collection. As you remember, the second image collection was related to the NDVI, but the image collection I actually added here was the first one that was the land cover data. So I think the problem should be solved now. Run a code, and now problem is solved, resolved, and also code works properly. Here NDVI data is ready, and now you can increase the contrast through the 90% of values we have in the data. Here, through the 90% of values, increase the contrast here. There it is, here the NDVI value, and you can compare the NDVI value for each classes that we have for the for each land covers separately. So, and in the next part, now I'm gonna show you how to do a statistical, I'm gonna show you how to actually do a statistical and how to apply zonal statistic using statistical functions that we have here. First, we must make a data set combining NDVI and land cover. Here, data set number 1, including NDVI and temperature. Earth engine.image.cat is a function allows us to combine or merge NDVI and land cover in a single TIFF file. Here inside the bracket, we will have NDVI as the first and land cover as the second band here. So if you print the data set here in the right panel, you will see our data set number 1. We have nothing as data set 1. There is an image with 2 bands, one of them NDVI and another one LC type 1. Next, make a new variable as zonal statistics. Zonal stats number 1 equals to get dataset number 1, and then through the reduce region you can calculate the average, minimum, and maximum NDVI value for each land cover separately. Here we have a couple of arguments. One of them is reducer, Earth engine.reducer. For example, I'm gonna have the minimum and maximum. If you want to have more reducers, while you are actually making a statistical query, it is important to use combine the current reducer with the combine the current reducer with another reducer. Combine allows you to define a second reducer, but remember, we have different combined functions. You must use those that combined function directly related to the reducer. In that case, you will have different arguments. The reducer number 2 will be Earth engine that reducer that mean. For example, we want to have average. You can leave output prefix as null and shared inputs should be true here. Now, the other arguments is necessary here. One of them is geometry. Region of interest is ROI, and a scale equals to, for example, 500 meter or 250 meter, because the spatial resolution for NDVI data is 250 meter. Let's print zonal statistic. Zonal stats number 1. Run a code. In the right panel, you will have a new dictionary that is under computing. After a few moments, you can see the different classes values for each class that we have for example, we have 6 classes for this region, but seems something is wrong, and also we must actually go through the zonal statistic to see that what the problem is, because here we have the average, minimum, and maximum for the whole of the region, not for each class separately. The problem is related to grouping, because we must group add a function as a group here to make a new field or to define a band that is the second band defined by number 1, and define a name for the group. As you can see, we have 2 bands, band 0, band 1. Band number 1 is a band I want to actually group the result based on. And you can define a name for that group. That could be land cover, and then run a code. In the right panel, a new dictionary is under calculation again. If you had any problem regarding the code, you can send your questions on my YouTube channel. You can put your questions on the comments, and I will check them and answer them as soon as possible. As you can see, we have 8 classes in this region. Then we have 8 objects or 8 elements. For example, land cover number 7. You can go to the land cover data to see that, yes, land cover number 7 is about the shrublands. Shrubland in this region, the minimum, maximum, and average NDVI calculated. For land cover number 9, you can see the range of the NDVI and average NDVI. Land cover number 9, if you want to know which land cover it is about kind of vegetation cover. And for each land cover that we have, although we have 17 classes in this land cover, but definitely we don't have all the classes together in one region. For each region, we have some classes and we don't the other classes, and also it is normal. We can try this method, and this is the method that helps you to get a statistical information or extract some kind of information based on region of interest you are working. There are a lot of reducers such as minimum, maximum, mean, and also the median. These kind of techniques helps you to get statistical information about different land covers. You can compare the land cover values from one year to another year. That would be very, very beneficial. So now imagine that we want to use this method, the same method, this time for the temperature data. For example, imagine that we have land surface temperature, and now I'm gonna actually extract the temperature of each classes based on modis LSD data that we have here. Another variable as LSD must be created equals to go for the modis LSD product. Here modis surface temperature data is available with 8 days temporal frequency with 1 kilometer spatial resolution. Open it into the code image collection. The third image collection must be assigned to the LSD, and then define a period of time you want to have image and get its statistical information. Again, I'm gonna actually estimate the temperature for each land cover using based on 2020 data, starting from 2020 ends to 2021. Couple of bands we have here. You must select the target band. If you go to the data characteristic in the bands here, you can see we have LSD day with 1 kilometer spatial resolution based on Kelvin. We have a scale factor that should be applied on the data. So here, as you can see, the target band is selected, and now I'm gonna get the median to avoid from extreme values and having an average same time, and then multiply your scale factor. The output now is based on Kelvin. The Kelvin is the unit of the temperature. If you want to turn it from Kelvin to degree Celsius, you must subtract it from a constant value. 273.15 is a constant value, allows you to convert the temperature from Kelvin to degree Celsius. LSD is calculated now, and now we want to have visualization using map.add layer, this time for LSD data. LSD that should be clipped based on a region of interest or ROI. Leave the visualization parameters empty, and the layer name will be the LSD, just like that. And use the false instead of shown to avoid automatic visualization. Leave the opacity, actually skip the opacity, and run a code again. After a few moments here, you can see the LSD data that is calculated. Here it is your LSD data. You can increase the contrast of LSD using 90% of value. Just go to the data setting and increase the contrast by 90% of values. The temperature in this region ranges from 6 degrees Celsius to 29 degrees Celsius in 2020. But the spatially temperature changes, you can change it. You can check it by the inspector. Here, when you click on a pixel, same time you can see the NDVI, correspond LSD, and also the correspond land cover that you have for the region of interest. And now we can get this information based on different land covers that we have. As you can see, already we used the zonal statistic for dataset 1. The simplest way, just copy and paste the previous code with another name. Here it is the dataset number 2, combination of LSD and land cover. Zonal statistic number 2 will be calculated for LSD number for the dataset number 2. Again, the second band or group band is the land cover that we want to get LSD based on, and the spatial resolution is 1000 meter. So we must actually here reduce the scale from 250 to 1000. Finally, just make a print from zonal statistic number 2. In the right panel, you will have another dictionary that gives you a short description about each land covers and also the temperature. As you can see, the number of land covers changes from the first to the second one. It is related to the scale value. It is related to the scale value. For example, in the previous example, we had a scale 250, and here the scale is 1000. You can also use 250 again, and this time in the right panel, a new dictionary calculated based on the scale value, because the scale defined how many pixels do we have in our region of interest, and when we have lower scale value, definitely a higher number of pixels considered for the analysis. As you can see, when I change the scale to 250, again we will have 8 classes here, and for each class the temperature calculated, and also you can see how much temperature changes from one classes to another class. Such kind of statistical query could be very beneficial for the time series analysis and change detection, and also when you want to explain the product characteristic, the land cover characteristic for your region of interest, such kind of query could be very, very beneficial. I hope you like this tutorial as much as I did, and I'm suggesting you try and do practice with this code. Try to increase your skills, specifically in the basic levels. If you go to my YouTube channel, you can find a lot of tutorials about the Google Earth Engine from beginner to different applications. If you had any questions or problems, feel free to reach me out on my YouTube channel, and you can pick the code example from the description box below the video. Thank you for your attention, and please share this video with other users in remote sensing community. Thank you for your attention.